Good morning to one and all present over here. Okay, everyone are very interesting in studying. Very good. Yeah, we have completed one unit successfully. Okay, you have to go through the first unit. Okay, the first unit is very important lesson in your subject. Okay, there are many derivations in the first unit. Okay, the derivations which I have taught you. Okay, you do it daily. Okay, then only it will be very easier for you to write in during your exams. Okay, write the derivations daily. Okay children, go through the 2 marks questions also, that is short answers and one words. Okay, side by side you complete first unit. Okay, there will be online testers also for you. Okay, so you should be well prepared. Okay, well prepared the unit 1. Now unit 2, that which is current electricity. The unit 2 is current electricity. Okay, what is electricity? What is electricity? We will make electricity so cheap that only the rich will burn candles. Do you understood? This is a verse said by Thomas Alva Edison. He said that we will make electricity so cheap that only the rich will burn candles. Okay. So we is very important in our day-to-day life, because without electricity we cannot survive. Okay. Now in the unit 1 we have studied about the properties of charges, isn't it? What is, we already studied, no, properties of charges at rest, that is electromagnetism, isn't it? Electrostatics, it is a branch of electricity which deals with stationary charges. Okay, we have seen about electrostatics in the previous chapter. Okay, for the rest bodies. So in reality the charges are always moving within the materials. Okay, in reality the charges are the positive charges, negative charges, electricity. Okay, always moving within the materials. So for example, electrons in a copper wire, okay, are never at rest. Okay, take a copper wire, there are electrons, no, inside that copper wire. The electrons in the copper wire are never at rest. They are continuously moving in a random motion. So therefore it is important to analyze the behavior of charges when they are in motion. It is important to analyze the behavior of charges. It is important to analyze the behavior of charges when they are in motion. So the motion of charges constitutes electric current. Motion of charges constitutes electric current. Do you understood? Motion of charges constitutes electric current. What is electric current? Motion of charges constitutes the electric current. Okay children, in this lesson we are going to see about the current electricity. Now, what is current electricity? It is the study of flow of electric charges. It is the study of flow of electric charges. Okay, the study of flow of electric charges, that is the current electricity. So it owes its origin to Alessandro Volta, who invented the electric battery. Alessandro Volta invented the electric battery, which produced the first steady flow of electric current. Now the modern world depends heavily on the use of electricity, isn't it? Our modern world depends heavily on the use of electricity. So it is used to operate machines, communication systems, electronic devices, home appliances, each and everything there is electricity. Without electricity we cannot survive in today's world. So electricity is very essential like water. Okay, so in this unit we will study about electric current, resistance and the related phenomena materials. Okay, first of all, what is electric current? It is the flow of electrons. It is the flow of electrons. Unlike static electricity, charges are in motion. Okay, in electrostatic the charges are at rest. Okay, electrostatic, static means at rest, but in static electricity the charges are in electrostatics the charges are in rest. But here electric current is a flow of electrons. It is not in rest. It is in motion. It is in motion. Okay. There are two types of current, that is direct current DC and alternating current, that is AC. What is direct current? The flow of electrons in one direction. Flow of electrons in one direction. It will not return, only one direction flow. What is alternating current? Flow of electrons back and forth in a path. But in direct current, only one time it will go. In alternating current, it will go and come again. Okay, that is alternative current. So, what are the examples for direct current? Car battery, flashlight batteries, okay, photovoltaic cell. These are the direct flow of electrons. And what is alternating current example? Electric generator. Okay, the generator is flow of electron up and down, back and forth. Okay. Now, our matter is made up of atoms. Okay, you already know that matter is made up of atoms. Each atom consists of a positively charged nucleus with negatively charged electrons moving around the nucleus. Okay, each atom consists of a positively charged nucleus with a negatively charged electrons. It is moving in a nucleus. Okay. So, the atoms in metals which is having one or more electrons are loosely bounded to the nucleus. These electrons are called free electrons. Loosely bounded electron. Okay, it is not tightly bound, it is loosely bounded. So, it is called free electron and can be easily detached from the atoms The substances which have an abundance of these free electrons are called conductors. The substances which have an abundance of these free electrons are called conductors. Okay, these free electrons randomly throughout the conductor at a given temperature. So, due to this random motion, there is no net transfer of charges from one end of the conductor to the other end. And hence no current in the conductor. So, the potential difference applied by the battery across the ends of the conductor, the free electrons drift towards the positive terminal of the battery, producing a net electric current. So, this is easily understandable. Okay, easily understandable one. Okay, in volume 2 in 11th standard in the unit 6, you may have studied the mass moving from higher gravitational potential to lower gravitational potential. So, likewise, positive charges flows from region of higher electric potential to a region of lower electric potential. So, negative charge flows from lower electric potential to higher. Okay, positive charge eppadi flow agudhu? Higher potential to lower. Negative charge flows from lower to higher. Okay, remember that. So, battery or electric cell, it creates a potential difference across the conductors. So, if there is a equal gravitational potential, then there will be no water flow. So, if there is a gravitational potential, water flows from higher to lower. Okay. For example, take a copper wire. Okay, take a copper wire of end A and B. If they are at same electric potential, then there will be no current. Okay. If A is higher than B, then there is a current. Okay. If there is a difference between the 2 points, then there is a flow of current. If there is the same, then there is no potential. Okay. This is the electric current. It is a flow of electric charges. See the picture. The charge, the conductor and the cross sectional area, there is a flow of electric charges. Okay. From higher to lower, then only current is produced. What is conventional current? Okay, the direction of a conventional current is the direction along the imaginary positive charge carriers may be imagined to a flow. Okay, what is a conventional current? In an electric circuit, the arrowheads are used. Okay, the arrowheads are used to indicate the direction of flow of current. So, by convention, this flow in the circuit should be from the positive terminal of the battery to the negative terminal. So, this current is called conventional current. Or simply current in the direction of the positive test charge. Okay, the electric current is not only produced by batteries. Okay, for example, in nature, okay, during lightning produces enormous electric current in a short time. So during lightning, a very high potential difference is created between the clouds and grounds. Okay, during lightning, very high potential difference. Okay, there is a difference. That difference is potential difference is created between the clouds and the ground. Hence, the charges flow between the clouds and the ground. Okay, in wire, electrons are the only charged particles moving in the electrical circuit. So, negative charges moving to the left is equal to the positive chargings moving to the right. So, in this way, conventional current is produced. Okay. Okay, we already saw what is conventional current. Conventional current is the current whose direction is along the direction of the motion of positive charge under the action of electric field. Okay, under the action of electric field, there is a electric field. Okay, okay. Now the current whose direction is along the direction of motion of positive charge under the action of electric field. Okay, this conventional current due to motion of electrons is in the direction opposite to that motion of electrons. Conventional current due to motion of electrons is in the direction opposite to the motion of electrons. Okay, due to the motion of electrons, it is in the direction opposite to the motion of electron. That is the conventional current. Okay. Now, what is drift velocity? In a conductor, the charge carriers are free electrons. Okay, in a conductor, charge carry பண்ணக்கூடிய every electron க்கு பேரு free electron because they are loosely bounded, they are not tightly bound. So these electrons move freely throughout the conductor and collide repeatedly. Okay, so if there is no electric field, then the electrons move in random direction. Okay, electric field அங்க இல்ல அப்படினா electrons அது இஷ்டத்துக்கு ஏதாவது ஒரு directionல போகும். So their velocity is also random. So on average, the number of electrons traveling in any direction is equal to the number of electrons traveling in the opposite direction. So as a result, there is no net flow of electrons in any direction. There is no net flow of electrons in any direction and there will be no current. So, suppose there is a potential difference. Okay, suppose there is a potential difference which is set across the conductor by connecting a battery and electric field in a conductor. Okay, that exerts a force on the electrons which produce a current. What happens? The electric field accelerates the electrons while ions scatter the electrons and change their direction of motion. Thus, we see a zigzag motion of electrons. So, in addition to the zigzag motion due to the collisions, the electrons move slowly along the conductor in a direction opposite to that of E vector. Okay, any material is made up of neutral atoms with a number of electrons and protons. Atom is made up of electrons and protons. Okay, so if the outermost electrons leave the atoms, they become free electrons and responsible for an electric current. So at that time, they need a velocity. That velocity is called drift velocity. So the drift velocity is defined as the velocity with free electrons get drifted towards the positive terminal. Free electrons get drifted towards the positive terminal. Okay, see then the picture, the drift velocity is coming towards the positive terminal under the effect of electric field. There is an electric field and the electrons drifted towards the positive terminal. Okay, what is the current is directly proportional to the drift velocity. Okay, it is represented by Vd. So Vd is the drift velocity. So mu equal to Vd by E vector, that is electric field. Okay, mu is the mobility of the electron. It is defined as the magnitude of the drift velocity per unit electric field. Okay, you have to there is a derivation for drift velocity. Okay, I will teach you in the next class. Okay, in this lessons also there are lot of derivations. Okay, first of all I am going to give a glance about this lesson. Okay, in the next classes I will teach you the derivations. Okay, these are the definitions. Okay, today we are going to see what is drift velocity, what is conventional current, what is electric current, and in the further classes we will going to see in mathematical expression. Okay, how the drift velocity came and how the expressions came, like that. Okay, children. Now, what is misconception? What is misconception? Okay, there is a common misconception that the battery is the source of electrons. There is a common misconception that the battery is the source of electrons. It's not true. So, when the battery is connected across a given wire, the electrons in the closed circuit resulting the current. Okay, So the battery stores electricity. The battery stores electricity. The electricity from both the ends of the battery. Electricity flows from both the ends of the battery. Now the electricity is used in the circuit. Electricity is used in a circuit. Battery runs out of charged particles. Battery runs out of charged particles. Battery runs out of electric current. Okay, battery supplies all of the charged particles. Okay, battery supplies all of the charged particles. We often use the phrases like charging the battery in my mobile, and my mobile battery also has no charge. Okay, these sentences are not correct. Okay, these sentences are not correct. This is the misconception. There is a common misconception. When we say battery has no charge, it means that battery has lost ability to provide energy. Okay. So, difference to the electrons in the circuit. So, we can say mobile is charging. Mobile is charging. So, it implies that the battery is receiving energy from an alternating current, that is a power supply, not the electrons. Okay, that is the misconception. Now, what is current density? What is current density? The current density is defined as a, okay, it is indicated by the letter J. Okay, so J equal to I by A. What is I? I is the current, A is the unit area. So you can write by the formula itself. Current density J is defined as the ratio between current per unit area in a conductor, where A is the cross sectional area. The current density is a vector quantity. Current density is a vector quantity. Its unit is amps per meter square. Its unit is amp per meter square. Okay, where Vd is proportional to the electric field. Vd, that is the, what is Vd? That is what? Drift velocity. Okay, so I, what is I? Current. I equal to NQA Vd. So J equal to NQVD. J equal to NQVD by A. So this is the expression. Okay, this is derivation I will teach you in the next class. Okay, you just you just remember what is current density. Current density is the ratio of current by area. That's all. Okay, it is proportional to the electric field. What? The drift velocity is always proportional to the electric field. So J equal to sigma E, where sigma is a constant called conductivity of the material. Sigma is a constant called conductivity of the material. Now, what is Ohm's law? Have you heard about the word Ohm's law? Ohm's, he is a scientist, okay. He is a scientist, he derived this law, okay. In Ohm's law, we can say what is Ohm's law means, it is the amount of current through a conductor is directly proportional to the potential difference and inversely proportional to the resistance, okay. This is also just the formula. R, that is the resistance, okay. R equal to V by I. You remember this formula, R equal to V by I. R is the resistance. The unit of resistance is ohms, okay. Ohm, the symbol see, that is ohm. So R is the resistance. Ohm's law states that the resistance is the ratio of potential difference. V is the potential difference. I is the current. So voltage, V, voltage, the unit of voltage. Voltage is the potential difference, no. So the unit of voltage is volts and the unit of current is amps, okay. This is the Ohm's law. Ohm's law, R equal to V by I. So in this formula is useful for many problems, okay. For solving voltage, what is voltage? Voltage equal to I into R. What is I? I equal to V by R, okay. R equal to V by I equal to V by R, okay. V equal to IR, okay. If in this you can remember it by a word, okay. I equal to what? V by R, and V equal to what? IR. V what? Voltage. Voltage equal to current into resistance. Write down V equal to I into R. You can remember it easily. Ohm's law. Ohm's law. I V equal to IR. V is voltage and that is equal to I current into resistance, that is IR, okay. What is vegetarian, okay. For such remembrance I will tell you, V for vegetarian, IR is the IR. Iyer will always vegetarian only. He's not a non-veg. He's always vegetarian. So Iyer as vegetarian. Like that you can remember IR is V. IR is V. By that formula you can write the Ohm's law. What is Ohm's law? It is the amount of current through a conductor which is directly proportional to the potential difference but inversely proportional to the resistance. That is the Ohm's law. What is resistivity? Okay, what is resistivity? Resistivity is a property of a material. Resistivity is a property of a material. It is how well the material conducts electricity. Okay, it is a property of a material. It determines that how best the materials conducts the electricity. Okay, electrical resistivity of a material is defined as the resistance offered to the current flow by the conductor of unit length and unit area. Unit length, unit area, that is rho. That is the rho equal to R into A by L. That is resistivity symbol. Okay. Rho is the resistivity symbol. Unit of rho is ohm meter. Ohm meter. Okay, this formula shows that resistance will increase if P increases or the length increases. Okay, the resistance will decrease if the area increases. So R equal to rho into L by A. So resistivity increases means length increases. Resistivity increases means A decreases. That is R and A are inversely proportional. R and L are proportional to each other. Okay. Now, what are the resistivity of various materials? It is given here. Okay, resistivity of various materials are given here. Okay, now let's see one by one. Okay, what are the conductors? Okay, what are conductors? Silver, copper. Okay, good conductors of heat. Okay, silver, copper, aluminium, tungsten. Okay, nickel, iron, chromium, mercury, manganese. Okay, these are conductors, and there are semiconductors, insulators, alloys. Okay, the conductors have lowest resistivity. Insulators have highest resistivity, and semiconductors have resistivity greater than conductors but less than insulators. Okay, here what are the conductors? Silver resistivity 1.60 into 10 to the power minus 8. Okay, you can remember it. In some problems it may be used. Okay, just you know, or some important terms you can memory. Okay, tungsten, aluminium, copper, iron, nickel, chromium, mercury, manganese, these are the conductors and their resistivity is given. It is expressed by ohm meter. Ohm meter. Now what is alloys? Constant N. What is constant N? Copper and nickel oda alloy da constant N. What is manganese? Copper, manganese and nickel oda alloy. What is nichrome? Nickel, chromium, manganese and iron. Okay, this is the nichrome. What is insulators? Glass, hard rubber, ebonite, diamond, paper. Okay, glass, hard rubber, ebonite, diamond, paper. Those are the insulators. Okay, the bad conductors. Okay, that is the insulators. Their resistivity is also given. Okay, these are the resistivity of various materials. Okay, the resistance of a material is directly proportional to the length. Okay, and inversely proportional to the area. You should remember the formula. Okay, now there are color codes. Okay, there are color codes. What is the color code? Okay, have you seen the resistors? It is in digital centers, electronics departments like that. Okay, you may not seen, but if you study engineering, okay, you can see. Okay, in electronics department, okay, there will be lab for it. Okay, so it is the basics of physics. Engineering subjects basics is physics only. So there is a resistors. Okay, carbon code, carbon resistors are there. There are different color codes for it. Okay, the carbon resistors consist of ceramic core. Carbon resistors consist of ceramic core on which a thin layer of a crystalline carbon is deposited. Okay, the resistors are inexpensive, it is stable and it is a compact in size. Okay, these resistors are inexpensive, stable and compact in size. Okay, color rings are used to indicate the value of the resistance. Color rings are used to indicate the value of the resistance according to the rules. So 3 colored rings are used to indicate the value. First 2 rings are significant figure. The next Third ring indicates a decimal multiplier after them. Fourth color, that is silver or gold, it shows the tolerance. Okay, ஒவ்வொரு resistance ஒவ்வொரு கலருக்கும் ஒவ்வொரு அர்த்தம் இருக்கு சரியா. first two ring வந்து significant figures. Okay, you already studied significant figures in 11th standard. Okay, so the color rings indicates the significant figures. The third one indicates the decimal multiplier. Fourth color, there may be silver or gold, it shows the tolerance of the resistor at 10% or 5%. So if there is no fourth ring, the tolerance is 20%. If there is no fourth ring, the tolerance is 20%. So for the resistor, okay, for a resistor, see your book page number 94. Page number 94, figure 2.12. Take your page, take your book, page number 94. Take your book, page number 94. Have you taken? Page number 94. Okay, see that 2.12, there is a resistor color coding. ஒவ்வொரு ரெசிஸ்டர்லேயும் ஒரு கலர் கோடிங் கொடுத்துருப்பாங்க. எதனால இந்த கலர் கோடிங் கொடுத்துருக்காங்க, இதுக்கு என்ன அர்த்தம், ஓகே, லைக் தட். அந்த ரெசிஸ்டரை பார்த்த உடனேயே அதை பற்றின எல்லா விஷயங்களும் நீங்கள் தெரிஞ்சுக்கலாம். தட்ஸ் த கலர் கோடிங். ஓகே, கற்று கொடுக்குது. ஓகே, வாட் ஹேப்பன்ஸ், சி த ஃபஸ்ட் டிஜிட். ஓகே, ஃபஸ்ட் டிஜிட் இஸ் 5. if it is green color, okay, அந்த மூணு கலர் இருக்கா, green, blue and red, isn't it, orange something, okay. green இருக்கு, blue இருக்கு, orange இருக்கு. okay, so first digit என்ன represent பண்ணுதுனா 5. first digit represents 5. so green color na 5. second digit வந்து 6, it indicates blue color. third one decimal multiplier, that is 10 power 3. okay, and the last one as a golden color, isn't it, that is 5% tolerance. The tolerance is 5%. so now you have to multiply the value. so 56 into 10 to the power 3, 56 into 10 to the power 3, that is 5 for green and 6 for blue. so 5 6 and 10 power 3 is tolerance, so into 10 power 3, so 5 6 into 10 power 3. do you understood, with the tolerance of 5%. so by knowing the colors, by seeing the colors, you can calculate the full biodata of that resistor. okay, carbon resistors are small, they are color coded to mark their resistance in ohms. okay, for see here இங்க பாருங்க, see the picture, black color க்கு 0, brown அப்படினா 1, ரெட் அப்படின்னா 2. அந்த ரெசிஸ்டரில் ரெட் கலர் அடிச்சிருந்துன்னா ஃபஸ்ட்டு டிஜிட் 2ன்னு சொல்லிக்கணும். செகண்ட் வந்து ஒரு க்ரீன் கலர் அடிச்சிருக்குன்னா தட் இஸ் 5. ஓகே, அப்போ 2 5ன்னு எழுதிட்டு அண்ட் தேர்ட் மல்டிப்ளையர் 10 to the power, எத்தனை 0 இருக்குது, 10 power 3, 10 power 4, லைக் தட் யூ ஹாவ் டு ரைட். அண்ட் கோல்டன் ஆர் சில்வர் இருந்ததுன்னா தட் இஸ் டாலரன்ஸ் 5 or 10%. ஓகே, யூ அண்டர்ஸ்டுட், ரைட். see the picture, black க்கு 0, brown 1, 2 இருந்துச்சுன்னா that is red, and orange means 3, yellow means 4, and green means 5, blue means 6, violet means 7, grey means 8, white means 9, and gold and silver, that is 0.1, 0.01, that is the multiplier. it is only for the fourth color. gold and silver will be in fourth color. okay, it indicates the tolerance only. okay, now இதை ரிமெம்பர் பண்ணுறதுக்கு ஒரு கோடு இருக்குது. பேட் பாய்ஸ் ரிங் அவர் யங் கேர்ள்ஸ் பட் விக்கி கிவ்ஸ் வில்லிங்லி. ஸோ இந்த கோட் இருக்குல்ல, பேட் பாய்ஸ் ரிங் அவர் யங் கேர்ள்ஸ் பட் விக்கி கிவ்ஸ் வில்லிங்லி. இந்த ஒரு வேர்டை, இந்த ஒரு சென்டென்ஸ், தட் இஸ் ஒரு கோட் மாதிரி நீங்கள் ஞாபகம் வச்சுக்கிட்டிங்கன்னா யூ கேன் ரைட் இட். ஸோ பி, பேட் பாய்ஸ், த ஃபஸ்ட் லெட்டர், ஸோ பி ஃபார் பிளாக் அண்ட் நெக்ஸ்ட் பி ஃபார் ப்ரௌன், ரிங் ஃபார் ரெட், O for orange, young for yellow, G for green. so 1 2 3 4 like that. B 0, next B 1, like that. இந்த கோட்டை நீங்கள் ஞாபகம் வச்சுக்கிட்டிங்கன்னா இந்த ஃபஸ்ட்டு இனிஷியல் லெட்டர்ஸில் இருக்கக்கூடிய அந்த கலர்ஸ்க்கு ஒரு 0 1 2 3 4 அப்படின்னு போட்டு okay, you can write by yourself. okay, if you are given 1 2 into 10 power 3 அப்படின்னு கொடுத்துட்டாங்க, you are told to write the colors. what you do, what is 1, that is, oh, you have to remember that bad boys, so second will B, that is boy, that is brown, like that you have to write. okay, this are used in some problems. okay children, have you understood? This is the resistor color codes. now it's time for your homework. okay children, up to page number 94. Today we have seen from 80 to 94, and some derivations are there. Okay, resistors in series and parallel. Okay, and Ohm's law. Okay, drift velocity. Okay, I will teach you in next classes. Okay, I will give you the videos. Okay, I will put my videos. Okay, and you have to study the derivations. Okay, now your homework is 10 one words. Okay, 10 one words from this topic. Okay, up to page number 94. Write any 10 one words and submit as a homework. Okay, write it in your homework note. Write the homework daily. Okay, you will be checked by our sir. Okay, next you have to make your assignment. Okay, assignment is Ohm's law, current density and electric current. Write the definition and formulae for these three: Ohm's law, current density, electric current. It is short answer. Write its definition and formula as a assignment. Okay children, have you understood? This is your homework today. Okay children, study well, don't waste your time. Okay, have a nice day. Thank you.